I would like to briefly introduce the first keynote, which is Professor Kevin Ashley from Pittsburgh School of Law. He is an expert speaker, a veteran in the legal informatics industry or society, you need to say. He's teaching law students about AI and text analysis, as is sort of his keynote topic. He will give you a great speech. I've heard something similar already, so I know what I'm talking about. But what you should know is that Kevin is an expert on computer modeling of legal reasoning. He had been in 2002 selected as fellow of the American Association of Artificial Intelligence. He has been a visiting scientist at the IBM J. Watson Research Center. He's a past president of the International Association of Artificial Intelligence and Law. He's reading in Pittsburgh legal data analytics and intellectual property law. He's an excellent teacher who has a vision for the education of lawyers in the future. He authored too many publications for me to mention. He chaired many conferences. He's a regular contributor to a number of scientific journals, so a great expert. And without further ado, I would ask Kevin to give us his keynote, please.
Thank you, Stefan. I'm sharing my screen and hoping that you're seeing the presentation. Can someone confirm? Adam, can you see the presentation? Good. So I'd like to send greetings from Pittsburgh, where it's a beautiful spring morning. I'd like to acknowledge my co-presenters, or rather my collaborators in this work, Jaromir Savelka and Matthias Grapmeyer. And as Stefan says, this is about training. The Legal Academy in the United States recognizes that artificial intelligence is changing law practice. In fact, 10% of accredited law schools are offering a course in AI in one form or another. Our course, Applied Legal Analytics and AI, has been offered on 2 successive spring semesters. This past semester, Jaromir Savelka, a data scientist, and I co-taught the course to a combination of law students and computer engineering. The course lessons and the homework assignments introduce the students to applying data analytics and machine learning to legal problems, culminating in final projects. And in this talk, I'm going to report some highlights, some lessons learned, and some future challenges. So here's an overview of the talk. I'm going to briefly introduce legal text analytics, explain why we teach AI and legal text analytics in law school, provide a brief overview of the course, and then focus on how we're introducing students to legal reasoning with text analytic tools, the Python programming, machine learning, and natural language processing through 4 homeworks and associated lectures. Speak a bit about how we're focusing on applying machine learning to legal decisions, showcase the final projects, report some of the students' comments and the lessons that we've learned, and some practical strategies for legal professionals in dealing with AI and legal text analytics. Artificial intelligence in law has been around for more than 30 years. It's a computer science sub-area where researchers build computational models of legal reasoning behaviors. And more recently, legal text analytics or text mining has arisen. It employs natural language processing machine learning, and various computational techniques automatically to extract meanings from archives of legal case decisions or contracts or statutes. And argument mining is a subset of legal text analytics that focuses on extracting argument-related information from these text corpora, such as premises and conclusions or sentence roles in legal arguments. Legal text analytics uses three techniques primarily: machine learning from legal text collections, legal network diagrams, and legal question answering systems. Machine learning involves computer programs that use statistical means to induce or learn a model from data with which they can classify a document or predict an outcome. Legal question answering to C focuses on searching large text collections to locate documents or short phrases or sentences that directly match and answer a user's question. And in this talk, I'm going to be focusing on those two techniques. So why do we teach AI and legal data analytics in law school? There are at least four rationales. One I call the practice-ready rationale. We want to get students to understand how the new technologies are changing the models for delivering legal services, and we want to get students to participate in these changes. There's also an emerging legal issues rationale. We recognize that AI technology is raising new questions of legal responsibility, due process, and regulatory frameworks. We want students to understand those new questions and how to analyze them. A third rationale is multidisciplinary teamwork. That is to say, students will need to participate in and even supervise multidisciplinary teams designing these new practice technologies. And the fourth rationale is limitations on reliance. That is to say, to what extent can attorneys reasonably rely on the new technologies? We think that students need to understand the algorithms and how machine learning models work in order to be able to evaluate them to answer this question intelligently. This artificial intelligence has been integrated in law school curricula in a number of ways. There's an embedding model where one includes high-tech examples and lessons in substantive law courses. For example, one could introduce contract analytic software in a contracts course. There's an entrepreneurial model where the course focuses on the business, tech startups, and innovation, training students to think like entrepreneurs, to understand the business of law and operations, and improve the processes that are applied in the field. There's the regulatory model where the focus is on getting students to understand the implications of the new technologies for the administration of justice and social benefits. For example, there's a course at Stanford that focuses on a fine-grained understanding of the sources of algorithmic bias. There's an engineering and management model where the idea is to expose students to legal project management and process improvement, legal design, document and workflow. And finally, there is a reliance, limitations, and evaluation model, where the goal is to apprise students of the problem of reliance. Now, why is reliance a problem? Well, machine learning, as applied to law, is a very odd technology. As Harry Searden put it, you're focusing, this technology is providing intelligent results without intelligence. That is to say, we're asking the profession to rely on tools that draw inferences from textual data, but where the tools don't necessarily understand what the text means. In addition, machine learning frequently cannot explain its predictions and results in terms that lawyers can understand. And in particular, these new legal tools cannot read texts like lawyers can. So we want to help students to learn how legal inferences are generated and how machine learning can be evaluated, and prepare them as well to work in multidisciplinary teams in their future practice. I want to say a bit about this point concerning reading and focus on a recent contest held by Law Geeks, an Israeli-based contract analytics company. They published a study, and it claimed that its product was more accurate than lawyers at performing contract assessment work on a sample set of non-disclosure agreements with an average accuracy of 94% versus an average accuracy rate for lawyers of 85%. Even more impressively, the lawyers took an average of 92 minutes to review 5 non-disclosure agreements, and the AI system took only 26 seconds. It's worth reading their report of this context. You can find it on the Law Geeks website. The task was to identify issues in 5 non-disclosure agreements where an issue is defined as the type of provision found in the non-disclosure agreement. So for example, there's an arbitration provision or a disclaimer of warranty provision or a definition of protected information, which is the issue of the provision in the non-disclosure agreement that defines the information that's protected, including the form of the information and the way it's disclosed. Notice, first of all, that issue identification does not mean reading a textually described problem or scenario and identifying and analyzing the non-disclosure agreement related legal issues that it presents. My take on this is it's not too surprising that the program outperforms humans at identifying instances of 30 types of provisions. And I don't deny that that's an extraordinarily valuable contribution. But if you submit a textual description of information or of a particular scenario and ask if the non-disclosure agreement covers it, the human attorney will probably still do much better. The program will know that a provision is a non-disclosure agreement's definition of protected information, for example, but it will not know what the text of the provision means or how legal issues that may arise, or in particular to due diligence risks, which is probably what the automated techniques are being applied to assist in. Text analytics, for example, cannot yet deal with indirect inferences from implicit information or draw inferences across multiple contracts. In those tasks, human attorneys will still have a clear advantage. Thus, reading contracts like a human attorney involves much more than extracting semantic information. And I think that's a very important lesson that we need to convey to law students. Of course, there's still the issue of how much programming to teach law students. Some people have argued for a great deal of coding for lawyers, but in our course, our focus is on engaging law students with computer code sufficiently so that they understand how the technologies work and how to evaluate them. And that means stepping law students through programming with Python notebooks and organizing teams of law students and technical students to work on projects where they implement code, design empirical evaluations, run experiments, obtain results, and engage in error analysis to see what the programs can do and what they can't do. In other words, we're teaching skills of evaluating machine learning applications to data. And as Murphy and Pierce put it, lawyers will not need to code, but they will need to understand how to apply and evaluate new methodologies powered by AI. Once AI becomes central to the provision of legal services, it will have to become central to legal education. So here is an overview of the course. It has 4 parts. In the first part, we introduce legal text analytic tools, Python programming, machine learning, natural language processing, artificial intelligence, and law. In the second part, we focus on computational models of case-based legal reasoning that have been developed in the AI and law area. In part 3, we return to applying text analytics to legal texts, in particular applying machine learning to e-discovery documents and to legal decisions. And in part 4, we focus on AI issues in the legal domain. Here is a visual overview of what we cover in the 26 weeks of the course. You see the parts 1, 2, 3, and 4 there. And I don't have time to go through this in detail, but I do want to point out that the 4 homework assignments that I'll be talking about take place in part 1 in the first third of the semester. And the other feature I want to mention is that we have 3 sessions focused on the projects, beginning very early with project session 1, and then another project session 2 at the end of part 1, and a final project session at the end of the course. We have selected readings to go along with these various parts. Again, we don't have time to go into this in much detail, but with respect to Python programming, we use Halterman's Fundamentals of Python Programming, a very readable text. With respect to legal text analytic tools and their effects on the law, we've focused on automation of the legal profession. With respect to machine learning, we use an example of Lex Machina, an early machine learning prediction program. With respect to
sorry, Mr. Ashley, can you?
With respect to natural language processing, we focus on sentence boundary detection, named entity recognition, recognizing cited facts and principles in legal judgments. In part 2, we focus on computational models of case-based legal reasoning using some chapters from a book that I wrote, as well as Katz and Bomarito's Predicting the Behavior of the Supreme Court of the United States. We have a focus on applying text analytics to legal text. This paper by Litras, Predicting Judicial Decisions of the European Court of Human Rights, and 2 follow-up works. And with respect to AI and legal domains, we focus on privacy, machine bias, and legal liability in connection with machine learning, such as automated vehicles. With respect to the readings, we use a very helpful procedure of 1-page abstracts. We ask the students to prepare a 3-sentence summary of the reading, focus on 3 positive aspects of the paper, 3 criticisms, we're just talking about a sentence each, 3 questions the students would like to ask the author, and a brief statement of how the reading relates to the student's research interests. And these we ask the students to submit before the class so that the instructors can use them to focus the discussion and address the questions that have arisen from the readings. So now I'm going to turn to how we introduce students to legal text analytics, Python programming, machine learning, and natural language processing. And I've focused I will focus on the topics that I've highlighted in blue from the course overview, beginning with introducing legal reasoning with text analytic tools. Well, how do you get students to be familiar with text analytic tools? I think the easiest way is to get them to use one. And so we involve students early on in using a legal question answering system It's called Louima Search. It was developed by my colleague, Matthias Grotmeyer, and we present an exercise in which students perform a bit of legal research with the program and use the results in order to write a memo. We give them a scenario. It happens to involve an Air Force mechanic who witnessed a fatal crash. He sees people die in a helicopter crash. He had worked on that helicopter. He participated in the rescue effort. Things don't work out well for him. He receives a general discharge, not an honorable discharge, because of alcohol abuse. He has psychological problems and symptoms. They may have been aggravated by drug consumption. He files for disabilities with the Veterans Administration, but they reject his claim for PTSD. And we ask the students to prepare an argument for appeal to the Board of Veterans' Appeals. Well, if you were to write a legal memo on that subject, you'd need to find the relevant legal standards and how to meet them. And you'd have to ask some questions, such as what's the overall legal standard for determining if a veteran is entitled to compensation for disability? What's the standard for proving that a veteran currently has PTSD? And these students have just begun. They don't have an expertise in veterans law. How are they going to answer these questions? Well, you can submit them to a legal question answering system. For example, to Louima Search, where you can simply input those questions or questions like them, and the program will retrieve cases and highlight sentences in the cases that appear to answer the questions. Students can read the highlights and if they're interested in the case, select the case and get the full text of the case. And that's what we ask students to do. We tell them to imagine that they're working in a veterans legal clinic. We'd like them to prepare a legal memorandum for appeal to the BVA of the rejection of the veteran's claim for PTSD. We tell them to use the results of the legal search that they performed with Louima Search. We provide some guidance on memo writing. There's a lovely text by Brostoff and Sinsheimer that's very helpful in this respect. We provide some general criteria for assessing legal memoranda. The students work with this basic legal question answering system. The non-law students get some practice with legal research and writing a legal memo, and the resulting memos have turned out to be, in 2 semesters, quite acceptable. Next, how do we introduce them to Python programming? Well, we've got very modest goals, small pieces of executable code, and guide them in adapting sample codes to addressing the problems in an exercise. We want to encourage students to explore links to Python resources for non-programmers. We begin with 2 lectures to introduce programming with Python. The first one focuses on the code layout, on primitive types and flow control. The second one on modules and functions and data structures in Python. We don't assume any programming experience. And the general technique is a guided walkthrough of Jupyter notebooks hosted on a Google Collaboratory platform. Let me focus on what those 2 resources are. Jupyter notebooks are web-based interactive Python environments for programming code, for executing code with large data files, and for plotting the results. The instructor puts a classroom exercise or homework assignment in a file. It has the code, a series of tasks, instructions of how to perform the tasks with a file of data that's provided. The students download the file, follow the instructions, respond to the tasks. They can even submit the completed notebook when they're finished for grading. And this is all done on a collaboratory platform that allows writing and executing Python in a browser. No configuration is required, and there's free access to GPUs. So it's a very convenient environment for programming. We follow up the lectures with a programming assignment, homework 2, that focuses on Peter Norvig's spelling corrector. This is a simple program that learns the frequencies of words from a document corpus. It utilizes its machine learning model to correct spelling of input words. And since the program learns a model from a text corpus, it's a nice segue to our treatment of natural language processing and machine learning later in the semester. This exercise introduces students in following the flow of a program, understanding each execution step, and reasoning about the program's flaws or weaknesses. We teach the students to read and understand the source code by asking the roles of different lines of code in the program, asking them to run the program with selected inputs, and elaborating on the results and explaining the results. Now we also teach the students about machine learning. Again, we have 2 lectures on this topic. We start with the concept of machine learning, of a machine learning model, and of training and optimizing the model. We focus on text classification via supervised learning. We introduce them to several machine learning models like logistic regression, decision trees, k-nearest neighbors. We focus on machine learning, on the experimental setup for a machine learning experiment and the evaluation. Again, we use a presentation and guided walkthrough of a pre-prepared Jupyter notebook. We use the notebook to demo turning text into features, for example, with a bag of words representation. We use it to convey training, validation, and test sets and how to set those up, and the use of k-fold cross-validation, a standard measure for evaluating machine learning programs. We introduce them to the evaluation metrics and to ways to inspect the results using a confusion matrix and error analysis. And we literally provide the sample code as a basis for the students to then work through a 3rd homework assignment. In the 2nd lecture, we provide a fully functional code to perform this machine learning experiment, and it goes from data preparation through evaluation of the results. Again, it's a guided walkthrough of a prepared Jupyter notebook using this time a statutory interpretation data set that Jaromir Savelka had created. And we walk them through downloading the data, exploring the data, preparing the data for use in machine learning models, including dividing it into training, validation, and test sets, training the model, a decision tree, a k-nearest neighbor, or a logistic regression model, for the simple text classification involved, and then evaluating the 3 models using the various metrics and confusion matrices. And in this process, they're working with resources from the scikit-learn library for machine learning experiments. It turns out, for those of you who are non-programmers in machine learning, that there is a wonderful set of open source software libraries. And our task in the course is to familiarize students with these machine learning and natural language processing tools that are available for Python programming within Jupyter notebooks. They include scikit-learn and spaCy. You can find tools for stemming words, assessing similarity of texts, machine learning algorithms, for the various machine learning algorithms like logistic regression, and for setting up cross-validations and so forth. We have to teach them how to plug the tools into the data processing workflow that's applied to the data sets. And this is one of the important functions of the course, getting students familiar with these relatively easy to use tools. We also have required readings associated with our various sections. So for instance, with respect to machine learning, we have readings that focus on alternatives like unsupervised learning, automatically clustering data to reveal patterns. We focus them on examples like Lex Machina, which illustrates applying machine learning to predict the outcomes of cases from texts. We have selected these readings as useful because students need to apply the machine learning concepts from the lectures in order to understand the articles. And they're writing those abstracts, those one-page abstracts with respect to the readings. Then we have a homework assignment 3 that is a basic supervised machine learning experiment. Basically, the students are adapting the tools in the lecture 2 Jupyter Notebook to solve the exercises in homework 3. Again, it leads students through the steps of a basic supervised machine learning experiment, downloading the data, exploring the data, preparing data for use in machine learning models, training the model, and evaluating the model. And we also included 2 optional exercises for using different classifiers from those introduced in the lecture and using a grid search to optimize hyperparameters. Then we turn to an introduction to natural language processing. Here, 2 lectures explain selected natural language processing concepts for practical use. We focus again on transforming texts into features for machine learning. And there's a 4th homework assignment associated with this. In the first lecture, we focus on NLP for search, information extraction, and summarization. We introduce some core subtasks, tokenization, segmentation, parsing, named entity recognition. We provide a brief intro for each of these subtasks and a practical demonstration with those tools available from the Spacey NLP library. We work through 3 case studies. The first is concerning sentence boundary detection in legal case decisions. It's easy for us humans to separate a text into sentences, not so easy, especially in legal texts where periods play such a role in citation and confuse the issue. The 2 additional case studies focus on recognizing named entities and recognizing case facts and legal principles. In that, we use a paper by recognizing facts and principles and legal judgments. And again, we're using a guided walkthrough of a prepared Jupyter Notebook or code to perform this machine learning experiment, now with NLP add-ons. Again, downloading data, exploring data, preparing the data for use in machine learning models, this time employing new natural language processing features, training a machine learning algorithm, and evaluating the algorithm. Why do I keep emphasizing that? Why have I highlighted it in blue? Because that is the basic thing that we're teaching law students to do. We're teaching them to understand this process of creating a machine learning program that can be applied to text and evaluating it. And there's a homework assignment to go along with this as well. The focus is on 3 approaches to text feature representation for machine learning, bag of words, static word embeddings, and transfer learning with contextualized word embeddings. That's a relatively new way of representing the texts. Again, the approach is to adapt a Jupyter Notebook that had been presented in the lecture in order to solve the problems in the new homework assignment. We provide some options there for training a model with different sorts of text representations. Again, the code covers obtaining, exploring, preparing data, training models, and evaluation. That's what we are trying to teach the students. And in this final homework, we've provided the example code to perform all of the tasks, even the optional ones. By doing this, we're also providing students with a solid basis of code that they can then use in their final course projects. I want to briefly point out that later in the semester, we return to applying machine learning to legal decisions, where we focus in some depth at that triumvirate of interesting papers that began with Alitris's paper that focused on automatically identifying fact-related portions of the texts of decisions of the European Court of Human Rights and predicting the outcomes, and two follow-up papers, one in which related authors applied the new language models for text-based prediction, including the BERT model, bidirectional encoder representations from transformers, and attention-based neural networks, and a paper by Medvedeva that provided a sort of critique of the Alitris paper, extended it, made publicly available the data set that it worked on. And again, the lecture focuses on leading students in exploring and preparing data, training models, and evaluation. And our final exercise in applying machine learning to legal decisions is to return to that LUIMA project. You remember I mentioned LUIMA search in connection with the first homework. This time we're working with a part of the LUIMA project that involves automatically identifying the roles that sentences play. By roles, I mean a sentence might be a statement of law, it might be a finding of fact, and if a program is able to identify those roles, it can do a better job of legal information retrieval. That was our claim, and in this paper from 2015, we compared it in an experiment with a commercial legal information retrieval system, and were able to show that taking these types of role information into account can help it do a better job of legal information retrieval. Okay, so all of this leads up to final projects. Apply what they have learned in the course, that procedure for obtaining data, exploring the data, preparing the data, training the machine learning model, and evaluating it, to apply that to a larger work that they had designed. We require that the project have an empirical component. It's not just a library research assignment. We want them to survey a data set and/or evaluate a machine learning model. It's an important part of the course. It counts for 50% of the student's final grade. It's a team effort. Each team has to have at least one law student and one technical degree student. This ensures that each team has sufficient knowledge and skills for a successful project. It also ensures that students with different backgrounds have to work together on the project. And our key lesson from the first time that we taught this course is one has to start this process of setting up final projects early in the course, literally in the second week in the course. And we had the first project session where we identified 3 interesting data sets, text data sets, suggesting that the projects deal with one or other of these data sets. We have the Enron email data set, a data set of Supreme Court database features that had been assembled by political scientists, augmented with the full texts of the Supreme Court opinions. And we had a third data set focusing on the veteran claims decisions. We also suggested project ideas for each data set. And after that first session, the students formed teams and start working on proposals of a project. We ended up with 3 teams, one with 4 members, the other with 3 members each. The smaller team happened to have been joined by a Duquesne law professor who was auditing our lectures. And in the 5th week of the course, we had our second project session where the teams present their project proposals in a 20-minute presentation with 10 minutes for discussion. And the instructors then would provide feedback and guidance. We also, in order to help them prepare for these presentations, provided a template where they described the legal domain problem that the students would tackle, the use case that it would address, the contribution that they thought it would make, and basically focusing them on explaining how to create and explore the data set and to apply machine learning models to realize some goal. All of the teams proposed their own project ideas. None of them used the ideas that the instructors had suggested. And then after this session, every 2 weeks, we met with each group to monitor their progress and to provide feedback. And these are the 3 final projects that resulted. The first, the Fourth Amendment test project, involved automatically identifying which US Constitution Fourth Amendment test for assessing probable cause to arrest, which test a court's decision applied, whether it was the totality of the circumstances test, a kind of factor test, versus a bright line test, which is a sort of elements test. The team wanted to get a program to automatically identify the test, and they even wanted to use a transformer-based language model, one of those advanced models like BERT, in order to do it. The second project was a justice vote prediction project, where they would use predictive features that they had determined were predictive based on statistical analysis and a multi-layer perceptron learning model to predict how a current Supreme Court justice would vote in a case, liberal or conservative. And a third project was a veteran representation project that would automatically determine from a case decision if a veteran was represented by an attorney before the Board of Veterans Appeals to correlate whether they were represented or not with the outcomes of the case. So 3 very interesting projects. And in the final 2 sessions of the course, the teams reported on their final projects. Each team had 20 minutes for a presentation and 10 minutes for a discussion. We noticed that in each team presentation, all of the team members presented, the law students as well as the engineering students, which was a good thing, of course. And there were some very nice results. The Fourth Amendment test project team had demonstrated that machine learning and the deep learning classification of the difference, the bright line versus the totality cases tests could be done automatically, at least for a limited corpus of case text excerpts that an expert had deemed relevant to the court's analysis. The accuracies were 71% for the machine learning models and 87% for the deep learning models. And we encourage the students to do some more work on this, hopefully over the summer, working with a larger corpus of the full text of decisions. If they can get that to work, they've got a paper for Jurix or ICAL this year. With respect to the Justice Vote Prediction Project, they identified features that were most correlated with the direction of a justice's vote. They had to do with the issue and the issue area of the case and the lower court decision. but they couldn't improve upon a baseline accuracy of the majority class with respect to predicting the way the justice would vote. Well, that doesn't matter. They had gone through this whole process of representing the data, applying the machine learning models, and evaluating the models, and that's, of course, the point. And finally, the Veteran Representation Project had this great plan. They did an extensive analysis of actual texts for patterns to indicate if a veteran was represented or not. They even came up with some regular expressions and rules in order to determine if attorney representation was involved in the case. But it turns out that one also then needs to determine who the attorney is representing. Sometimes it's the veteran, sometimes it's the widow of the veteran, that kind of thing. And so the project kind of petered out before they applied the machine learning method, and they didn't attempt to correlate whether the veteran was represented or not with outcomes. Still, they had done a lot with respect to the preparation of the data and setting it up for the experiment, and we were impressed with the result. Now let me turn briefly to the students' comments, especially with respect to programming instruction. Jaromir Savelka was primarily responsible for teaching the programming instruction, and the students were very complimentary, credited him with teaching basic coding skills to achieve helpful machine learning tools for legal work. They liked the CoLab notebooks. They thought that his lectures on techniques with the example code were very thorough, accessible. In fact, they praised him as making learning it fun as a wall of code can be. I guess programming is never completely fun, but it seems like he did an excellent job. They even called for more examples with CoLab notebooks and legal data sets to help with the instruction. With respect to the projects, we noticed, whereas in 2019, the team's project reports focused on lessons learned for improving the timing and process for choosing projects and teams and data sets. This past spring, the project reports focused on substantive lessons learned from the team's particular project experiments and activities. And we thought this was a good thing. I think that we finally have managed to figure out how to introduce final projects early in the course and to improve the likelihood that the projects will be successful by the end of the course. On the other hand, the students had some suggestions. The law students, one complained, do not have a background in machine learning. My group primarily rested on technological skills of the undergraduate CS major, and our limited skills, which I learned for the first time in the semester. This made the project very hard and compounded internal group frustrations. The fact is that programming is hard. Getting law students to do it and apply it in machine learning is frustrating, and we have to try to make it as feasible as possible, although we can never completely remove the frustrations. And that's our challenge for next spring. We'll be offering this course again. How can we help the students with little technical background to become more productive and to ensure that they are engaged in the technical aspects of the homeworks and the programming projects, the final projects? How can we better integrate the law students in programming instruction and in programming aspects of the projects? We've been thinking about possibly different homeworks tailored for each group, the law students versus the technical students, and thinking about ways that we can engage the technical students in providing feedback and assistance to law students about the programming exercises. Now I'd like to focus on some recommendations for priorities in shaping a law firm's AI strategy. And I think the first and foremost is that firms should establish a firm-wide AI committee that includes the attorneys as well as the computer technical staff. And that together they develop a culture of legal process engineering. That is to say, they need to institutionalize habits of managing, of identifying the firm's data sources, and law firms have plenty of data, and how to manage those data sources, and to identify the text analytic techniques that could add value. The automation of the legal profession article authors said it best: firms should engage with their different practice groups and attorney levels along with their technical, operational, and administrative staff in order to understand which tasks could be accomplished through automation. I think that's key. They also need to establish a sourcing strategy. Should they employ external vendors or should they develop in-house? There are pluses and minuses for each of those choices. For example, with respect to employing external vendors, there's the question of maintaining control over one's data and the fact that one would then become dependent on the vendor's expertise and rely on the vendor's representations, and that's always potentially problematic. Or you could develop it in-house, where it's easier to arrange the required maintenance and easier to arrange for the continual adaptation of the tools. These tools always need to be adapted as each new project comes along. And if it works, the firm might well be in a position to license the software to outsiders. I also recommend that the firms support technology, education, and research. Almost all of the law firms are in cities that have universities with sophisticated computer science research departments, where a fair number of the researchers are focusing on machine learning from texts, and some of them might even be focusing on AI and law. And the firms, I think, need to think about supporting the legal faculty in teaching students and new associates about the new technologies. And finally, the firms should establish criteria for choosing and purchasing and even developing AI tools. Somebody in the firm needs to understand the assumptions on which the AI machine learning analysis is based, understand the data that's being used. Somebody needs models for features that impact predictions. Somebody needs to try out the programs on known data and results to understand how the system is evaluated and what the evaluations signify, to perform error analysis, to discover errors and miscalculations in the program. Somebody's got to need to do that in the firm. Well, who? I think it's the graduating law students who get jobs with the law firms who need to have the skills to engage in those activities on behalf of the firm. I think it's the younger associates in the firm who need to be involved with this. And for that, they're going to need the skills of obtaining, exploring, and preparing data, training machine learning and natural language processing models, and evaluating them. And I highlight that in blue again because that is exactly what we are attempting to teach in our course. And with that, I'll conclude. We think law students can benefit from learning to design and conduct experiments with legal texts and data. Our course aims to teach these skills and knowledge to prepare students to perform those tasks. We want to make them aware of the problem of reliance on these new technologies, to learn how to evaluate the new technologies, and we want to prepare them to engage in the opportunities for multidisciplinary interactions that are likely to occur in law firms in the future. And in particular, our 2020 version of the course focused on the utility of progressively extended Jupyter notebooks to introduce law students to Python programming for machine learning and natural language processing. And if you do this successively, adding the new features and new aspects of the models, you can enable them to tackle new tasks in the homeworks and final projects. And I think they'll get these skills. And finally, I think we've shown that productive team collaboration between law students and technology students in the final projects is possible and can even result in some really sophisticated outputs of final projects. And with that, I will end and turn it back over to you, Stefan.
I hope you can hear me.
I can.
Good. Now we would like to move over to Q&A. We have a couple of Q&A, also some here from the panel. And I think there's sort of categories. One category is, what feedback do you receive from your class? Generally, in terms of, do they like it insofar as they would later on continue to use it in practice?
I'm not sure that I have information about whether they'll continue to use it in practice, but they do seem to like it in that in the anonymous comments at the end of the course, they said that they would recommend it to other students to take, which is a positive sign. As I mentioned, the law students, I think, find it frustrating to engage in programming, and indeed programming is time-consuming and frustrating. But I think they're convinced that it is important for their futures, and they do find this useful, and they'll expect to take it along with them in their future practice.
Okay, because the sort of the other side of the coin also came up in a question, which is, would the students rather like to stick to the traditional curriculum of education rather than to engage with new technologies?
Well, I have a biased sample, I think, because the students who are willing to sign up for this course already are predisposed to believe that this kind of thing is going to prepare them for the future. I have to tell you that I'm only dealing with a relatively small sampling of students. So the course in 2019 involved 14 students. This course involved 11 students. We're not talking, that's a rather small percentage of a law school class, which at our law school is about 130.
So conclusion is people still are not running in droves to the courses.
No, and one of the difficulties of law schools in the US is how does one prepare the student body more generally to the effects of technology, given that so many of the students who go into law are not disposed to go into programming or studying evaluation techniques for machine learning, but they still have to be apprised of the problems of reliance on the new technologies. They still need to understand something about what those technologies can do and cannot do. And that's where the techniques that I mentioned at the beginning of embedding the lessons about technology within other courses, substantive courses in law school, that might be the best we can do. So putting contracts analysis software for a week or two in the contracts course might be very helpful.
What would you think is necessary to sort of get students more interested and more ambitious in this context?
Well, I think for one thing, one needs to apprise them of the existence of this. I think that having people like the members of the audience here and the participants in this conference go into the law schools and speak on the subject might be a useful starter. I I get upset when I think of their only exposure to the new technologies as coming from the commercial providers of the new technologies, who I think tend to make very broad claims. They tend to use language like computers reading the contracts that are misleading. I think that a speaker at a lecture in a law school for the law school as a whole could at least sensitize students to some of the possibilities of the new techniques, but also some of the responsibilities that go along with them.
Do you think that sort of the future employers are not putting enough pressure on the new incoming sort of qualified practitioners, new practitioners? Is the job market not putting enough pressure on them to get themselves educated in that context?
I'm not sure because there seems to be a focus from some of the larger firms in Pittsburgh on the new technologies. For example, you might have noted that Jaromir Savelka, my co-instructor, is on the staff at Reed Smith, which is a large Pittsburgh law firm, an international law firm. And Reed Smith has a spin-off that has been creating this sort of technology. In fact, Jaromir did an internship one summer with Reed Smith and invented something for them that turned out to be a program that they're actually licensing to competitors nowadays. So there is awareness of the opportunities. There is some focus on getting law schools to recognize that the students need to prepare to deal with the technologies, but there isn't agreement yet across legal academia or I think across law firms on just how to do that.
Now, sort of turning to another sort of category of questions, is there any interest of cooperation sort of by your law school with external providers of technologies or services or research projects?
I'm trying to think of some examples of in-house corporate legal departments that are engaged in this. I certainly know that they're engaged in the research. For example, have been projects for companies that have huge corpora of license agreements, for example, to apply techniques like the IBM Watson programs techniques to analyzing those contracts and enabling a program to answer questions about the contracts. It could be even simple questions like, are provisions dealing with a particular topic in the body of a contract or in an appendix to the contract? It turns out that if it's in the appendix, it's cheaper to modify. And just getting a machine learning program to understand the structure of a contract and what's in the body and what's in an appendix can be useful. So I think the corporations recognize that they have an important resource. Incidentally, the fact that machine learning tools have been applied in e-discovery so extensively in American litigation means that almost all the big law firms and big corporate legal departments have machine learning programs running in their business already. And over the last 2 years, I would say, it has dawned on them that it isn't necessary to wait for the emergency of a big lawsuit to start that process, to harness that data and start learning things from that data. And so I think there's been a gradual incorporation of the machine learning text contracts analysis tools, for example, in the workings of corporate legal departments.
But so the other way around, would you be interested to sort of have project ideas for your classes put forward to you?
Yeah, by all means. I mean, I have tried over my career to find ways to cooperate with legal publishers or legal departments, whether in firms or in corporations. I think there's great potential for that, but it's a little hard to work out the connections. Law firms in the U.S. in particular tend to be income oriented. They're not. They don't have large finances to support research, as far as I can tell, or at least they haven't been willing to throw it in my direction. That's why I emphasize the importance of identifying the computer science departments in the universities near the firms, because there are people graduate students doing research that could, where the graduate students are desperate to find large sources of data, large corpora of texts. The firms have those, and some interesting stuff could easily come of that. It's a question of getting the universities to have a template for the appropriate sort of subscription agreements to work out with the corporation, and I think that can be worked out. It's just hard to do. It's hard to get the process started.
The question sort of also got in the direction, do you have sort of your course projects per semester, or every new class a new project, or is it continuing?
In our two semesters thus far, the course projects have been per semester. As I mentioned, the Fourth Amendment project, I think, is a project that could be published as a research project with some additional work on it. And that will continue, I hope, over the summer. The students seem to be interested in continuing it. I hadn't thought about the possibility of trying to pick up a project at the beginning of the next spring semester, but that's an interesting thought, and I'll consider that. Thank you.
Another question, sort of in the direction of standardization a bit, is sort of, would you think that open source legal NLP sort of focuses would be better than to have rather isolated approaches as we see it at the moment? And another question in that direction is, would you think that students would be interested in contributing to open source?
Well, there's a lot of issues that arise in that connection. I mean, one of the main contributions to research in the field is to make a large corpus of text data available as an open source resource that researchers can work with. Of course, this is something that requires care on the part of a law firm or a legal corporation, since the corpora have to be scrubbed and made anonymous. But to the extent that the corpora are made available publicly, then they become a resource for the research community, and good things happen. Progress results. I'm focused also on trying to harness AI and legal text analytics to make legal resources available to the public. We call that access to justice. And I'm hoping to work closely with the legal information institutes like Cornell, LII, and the Canadian Legal Information Institute in using some of the tools that Jaromir has developed for his recently successful dissertation, and my other student is working on to help the LIIs make legal resources available and tools for helping the public to understand the resources. For example, to easily find sentences and texts that apply statutory concepts and help to flesh out the meaning of the concept, or tools that can summarize the argument in a legal decision. We want to make those open source tools.
Allow me one final question, because our time is now running out. But if you would have the ability to look into the future, what is your expectation? Sort of how quickly will the need for technically trained lawyers in practice be increasing significantly?
I think it's going to increase steadily. I'm not sure just how dramatic the increase will be. I sort of think it's kind of a upward slope, less than a 45-degree angle, but it's just going to stay that way for the foreseeable future. So I see opportunities there. I think that the law students who take the time to learn some of these skills will not regret it.
Thank you very much, Kevin. That was just excellent. And I think from all the comments I see, we are not able to put all the questions forward, so we will try to have them answered on the chat later on.
Okay.
We are getting to our break now, and would welcome you back in about 9 minutes at 4:40 p.m. Our time here is Central European time.